Hello everyone, this is Mukundan Raghavan, and this video we are going to see what is vector actually. In previous video we have seen the everyday use cases of vector database. Since it is going to be a in detail vector database essentials, let's understand what is vector actually. If you are from the different backgrounds such as mathematics, IT field, or if you are from the statistics, everyone will have their own definition. But let's try to understand what is vector. A vector is a list of numbers that represent the data points. Maybe you can consider a list of numbers. However, in science, we have magnitude and direction. For example, in 2D, you will have the x-axis and y-axis. In order to point any point in this plane, you need to have the x-coordinate and y-coordinate so that it will have the direction as well as the magnitude. Same way, if you go to the 3D, you will have the x, y, z and also the direction. So this is where you will understand the vector in the very basic level. You need to see in the other perspective. Since we can see and imagine only at the 3D, 3-dimension level or the directions, we could see this in the diagram. Whereas if you have the multiple dimension, it's not only talking about the directions, but also talking about the features of the any kind of data. For example, mathematical representation for 2D and 3 could be well enough to understand this. Whereas if you have some kind of information, let's say some statement, I love cats, then this could have multiple dimensions, whereas some of those can be representing the sentiment, some of them might be for the object, some of them might be for the color. So that means that the more dimension you provide for the data, it will be very easy to find the similarity between the two different entries. So that's the reason we will have the more dimensions in case of if you are representing any kind of data. So that means that the number of features or the number of dimensions is directly proportional to the exact word matching or the exact entity matching. Let's get into some kind of example here. For 2-dimension, as we all know, it could be only two things, x-axis and y-axis. Whereas for 3-dimension, it would be only three. But as we discussed, some kind of vectors may be having the 5-dimension where you need the 5 inputs, 5 list of items, 5 list of numerical values to represent the single item. So this is where the 5-dimension or n number of dimensions appears. As we discussed here again, it could be color, intensity, tone, shape, sentiment, or even it could be something else. So now we have clearly understood dimensions are nothing but the number of items inside your list, and vector is nothing but a list of numbers. For generative AI perspective, this is well enough to start to the next level. Now the main question arises, who creates the vectors? Basically, you might have the unstructured data such as audio, text, videos, or any kind of unstructured data will be given to the model. Here you can see the text model, videos model, audio model, even general you can call as an embedding model. We are not going to very detail at this point of time about the models, especially embedding model and RAG. We are just getting into the high level who converts this unstructured data into vectors. In simple words, embedding models. After converting the unstructured data into the vectors, it will be called as a vector embeddings, a numerical representation of your data. If you see directly the vector, you may not get any idea what does it mean. But as a model, it converts with some logic. When you give the query again, then even your query will be converted into the vector. And now you can see the similarity. But that's what we are going to do this in this series. Let's proceed further. Now, since you have understood what is vector and how the embedding model works and how do we save the vector and what is the dimension of the vector, everything we have seen, even we have understood, if you have the high dimensional vectors, that means that you will have the similar results. So now with this, we are going to get into the vector databases. Currently in vector databases, we have multiple service providers such as Pinecone, Quadrant, or let's say Chroma, and what are the things you see in the screen. So this kind of vector databases are available, and you can get into that more on this. And whatever the companies or whatever the service providers that you see here, they are purely from the vector database perspective. Whereas we have already traditional databases such as PostgreSQL or Cassandra, Elasticsearch, Redis. So even some of the existing traditional database service providers also trying to support the vector search, which means that these concepts will be helpful no matter you use the dedicated vector databases or use the database that supports the vector search. Now try to understand what are the things we have seen. So now we actually understood what is vector. In mathematical representation, we have seen in 2D and 3D, whereas in our data point of view, it might have n dimension of data. So that means that you might have 5 dimension, 10 dimension, 100 dimension. And when you go for the higher dimension of data, you will have the more clarity and more similarity of results that is coming out. And we have seen who converts this unstructured data into vectors. Very simple answer is embedding model. We will be getting into that embedding model in later stage of the videos. But as of now, embedding model is the one who converts the unstructured data into the vectors. And we have seen some of the vector databases currently available in market, which are dedicated for only vector database. However, we also understood there are some databases which also supports a vector search. So obviously learning about more vector databases will be helpful either we for dedicated or the databases that already supports the vector search. So this is all about this video, and always be a rainbow in others cloud.